Hello and welcome back. Today we're going to be exploring absolute values and solving them, but with an inequality symbol. So it sometimes changes things drastically and sometimes doesn't. But let's get into it either way. Okay, this is also going to be some of your assignment, so I'm not going to be doing every problem because some of it is your assignment. Just like yesterday, as long as the absolute value bars are isolated or by themselves, you can do 6n is less than or equal to 18. But what is different, when you do the negative 18, you have to flip the inequality symbol. So here we got 6n less than or equal to 18, and then 6n greater than or equal to negative 18. So we got to do both. And when we divide, we get our answer. We get n is less than or equal to 3, and n is greater than or equal to negative 3. Now notice how I did not flip the inequality symbol here. When you divide by a negative, you do flip the inequality symbol. You may remember from like forever ago math, algebra 1-ish times, that when you divide by a negative, you flip it, but when you divide a negative number, you don't. Okay? So here we got 3 filled in circle. I'm going to do it above the graph so you can see it a little bit better, but it should be on the graph, technically. I like doing it above so everybody can see it. And then we have the negative 3 filled in circle. It would be a hollow circle for the ones without the inequality symbol, like the equal to sign underneath. Like number 3 is going to be a hollow circle because it doesn't have that equal to sign. And if it is with the variable on the left side, we graph in the direction that it goes. So here we're going to go to the left, or where it's less than 3 and where it's greater than negative 3. Ta-da! Now tomorrow we're going to be confirming our answers. These have a different way of checking your answers, and the way you would have to check it is by plugging in a number in each individual zone. Like if I plugged in negative 5, that's like not supposed to work because that's not a part of my answer set. My answer set would be any number in between negative 3 and 3. So if I plugged in the number 0, for instance, it should work. Let's see if it does. If I plug in the number 0, 6 times 0 is 0. Is the absolute value of that less than 18? Well, 0, last time I checked, is less than 18. It worked. So for today, let's plug in a number where we're expecting to get an answer. And then tomorrow we might have to shake things up whenever we do our review session. Okay? Number 3. Already isolated absolute value bars, so we can do our equations. I am going to attempt to do them right over here, I guess. M minus 2 is less than 8, and M minus 2 is greater than negative 8. Flip the inequality for the one that we switched the sign for. Add 2, M is less than 10. Add 2, M is greater than negative 6, and negative 8 plus 2 makes negative 6. Negative 8 plus 2 makes negative 6. Hollow circle, and hollow circle because it doesn't have the equal sign. We are less than 10 but greater than negative 6, so greater than negative 6 going to the right of that, and didn't mean to go that far, that should be still hollow. Still hollow. Less than the 10, so going to the left of the 10. And it's an in-between as well. Again, I would like you to plug in a number to check to see if it works. So you can plug in any number in between negative 6 and 10. So I'm going to plug in an easy one. Let's plug in 4. If I plug in 4, now let's plug in 6. 6 minus 2, the absolute value of that has to be less than 8. Well, 6 minus 2 is 4. Is 4 less than 8? Yes. So that is a right and correct answer. You're going to find that these inequalities sometimes don't have right answers sometimes. They just don't. Okay? Keeping right along, I might end up doing most of the left-hand column here. We got absolute value of x plus 5 equals 11. In order to solve this first, I have to subtract the 5. If I take that x plus 5 with the absolute value greater than or equal to 11, I have to first subtract the 5. And then I get absolute value of x greater than or equal to 6. Absolute value bars can go away, and we can get x is greater than or equal to 6, and x is less than or equal to negative 6, because I flipped the inequality sign here. So here, filled in circle on the 6, filled in circle on the -6, and we got to be careful. These aren't going towards each other. We got to go greater than or equal to 6, so it's going to go the direction that it's pointing. That arrow is pointing to the right. My graph has to go the direction of the right, and my arrow is pointing to the left for less than, and I got to go to the left. Well, here I need to plug in two different numbers. I need to plug in a -8 maybe, and maybe like a 10 or something like that to see if it works out. So if I plugged in a -8, what is -8 absolute value plus 5? Is that greater than or equal to 11? Well, -8 absolute value, that is 8. 8 plus 5 is 13. 13 is bigger than 11. It worked out. Check. It worked out. What if you plugged in the number 10? Well, 10 plus 5 is 15. 15 is, of course, bigger than 11. So some of those you don't have to write down. You can do it a little bit in your head, but you need to make sure you're doing it. Make sure you're doing it, because there can be some issues, especially when it's supposed to be less than a negative number, or even less than in general. Sometimes have issues. So maybe number 9, it's got a negative number and it's got a less than symbol. It's hard to be less than a number with an absolute value because when it's less than, sometimes you can't be less than certain things with absolute values. They always have to be positive. So let's try number 9. Let's give it a shot. We got to first add the 5. If I add 5, I am going to get something. Let's see here. I was trying to find some scratch paper. Believe it or not, got paper all over the place, but not a lot of scratch paper. In fact, like none. I have no scratch paper. I'm sad. Add 5. What happens if we add 5? We got x minus 2 absolute value. If I add 5, I get less than 3. So I added 5 over. And now I can drop the absolute value bars. X minus 2 less than 3. X minus 2 greater than -3. If I add 2 to that one, I get x is less than 5. If I add 2 to this one, -3 plus 2 makes -1. Fail. X is greater than -1. So x is less than 5, x is greater than -1. Here's my 5, hollow circle. Here's my -1, hollow circle. It looks like these are going towards each other, which is a thing when you have a less than problem, that they tend to go towards each other. And when there's a greater than one, it tends to go away from each other. But that's not always the case. Not always the case. Okay? So I'm going to move all the way onto the back. I want to see what happens here. Here, we have a few problems we're going to do. We're going to end up doing probably number 15 and maybe one of these down here. If we have -8a minus 3 greater than 11, because the absolute values are already by themselves, so I can drop them immediately and solve -8a minus 3 less than -11, flip the inequality, change the sign. Add 3, divide by -8. If we add 3, -8a greater than 14. And then when we divide by -8, you have to flip the inequality again, because we divided by a negative. -14 divided by -8. Boy, I struggled through that one. 14 divided by 8 is a -1.75. -1.75. Here, hopefully it won't be a decimal. Add 3. -8 less than -8. A. Divide by -8. Divide by -8. A would be greater than 1. Because when you divide by a negative, you flip your inequality symbol. When you divide by a negative number. We were dividing by -8 on both of them. So we have -1.75, hollow circle in between -1 and -2, and +1, hollow circle. It needs to go to the right of the 1 and to the left of the -1.75. Now this one really feels like a problem that I should check my answer. I don't know if they're going to be right or wrong. I have no idea, guys. But it does feel like I should be checking some of my solutions here, because We divided by a negative number. These inequalities were flipping all over the place, so maybe instead of moving away from them, maybe they should have moved towards, or maybe they don't exist at all. We need to check our answers. That's the bottom line. So a number smaller than the negative 1.75 would be, let's go with negative 4. Negative 8 times negative 4 minus 3 ends up being 32 minus 3. 32 minus 3 is like 29. Is 29 greater than 11? It is. 29 is in fact greater than 11. So this zone right here worked out. I'm testing the zones. And then we can plug in a number just bigger than 1. So a number bigger than 1, that could be 3. Why not? 8, negative 8 times 3 minus 3. The absolute value of that has to be greater than 11. Well, negative 8 times 3 is negative 24. Negative 24 minus 3 is negative 20-something, which is negative, but the absolute value of negative anything bounces to a positive. So that might be negative 27. The absolute value of negative 27 is 27. And last time I checked, 27 is greater than 11, so that worked as well. All right? One more. There is another bonus video on the absolute values with inequalities if you feel like you need them. So there is a bonus video for these. Let's see. Let's do number 25. It looks like there's plenty of space down here for me to be able to work. Subtract 3 first. Subtract the 3 first. 4, absolute value, 3x plus 7, greater than or equal to negative 86. Wrong again, negative 92. When you subtract 3 from 89, you get negative 89, you get negative 92. We cannot distribute the 4. Do not distribute the 4. You have to divide the 4 off. Do not distribute the 4. We learned that yesterday. Do not distribute the 4. 92 divided by 4 is 23. So we got 3x plus 7 greater than or equal to 23. It's the absolute values of that, which means once they're isolated, you can do 1 is greater than 23, and 3x plus 7 is less than or equal to negative 23. Change the sign, change the inequality symbol. Solve them both. Subtract 7, subtract 7. 3x greater than or equal to 16. Subtract 7, subtract 7. 3x less than or equal to negative 30. So you're realizing that sometimes these are going to be decimals too, and that's okay. Decimals are a thing. 16 divided by 3 is 5.3 repeat. So x is greater than 5.3 repeat. And then I know what 30 divided by 3 is. 30 divided by 3 is 10. So negative 30 divided by 3 would be negative 10. Oh, it's off the graph. Oh my goodness. 5.3, filled in circle. To the right. Negative 10, it's over here. Filled in circle. To the right. So negative 10 filled in to the right. 5.3 filled into that way, and they're going the right direction. So we had to go, I think I said right, left. It goes to the less than negative 10. And I would still recommend plugging in a number to make sure it makes sense. And to keep it consistent, let's plug in 10 over here. If I plugged in 10, let's test out the number 10 because 10 is in this zone. 3 plus 4, blah, blah, blah. That's a lot of math. 3 plus 4. Absolute value 3 times 10 plus 7 has to be greater than or equal to negative 89. And this feels like it's going to be right because negative 89 is negative. And everything over here is positive. But let's just confirm it. 3 plus 4, 37. 4 times 37 is like 120 something. 120 something plus 3 is definitely greater than or equal to negative 89. So that zone works out. And if we plugged in negative 10, it would almost be the same exact scenario. What would change if we plugged in negative 10? Well, instead of it being 37 here, I think it'd be 23. and negative 23, even if it's absolute value, would still all work out. So it's okay to not actually go through every step of plugging it in if you plug it in enough to understand it. So like, look here. Like here, I knew that would be negative 30-ish, plus 7, negative 20-something. Negative 20-something, the absolute value is going to make it positive. 4 times 20-ish is a lot. 4 times 20 is like 80. Plus 3 is going to be greater than negative 89. I don't have to go through every single step outright on paper to be able to get to that point. You can, by all means, you definitely can, but don't waste time with the checking part if it's something you can kind of do in your head. All right? So that's it for this video. Until next time, stay positive. I think I forgot to tell you to stay positive last time, but I will see y'all later. Goodbye.